Guys, you can see this is a step to check the given system and whether it is the LTI or not. Uh, in this system, you can see there is a input is there x1t and its output is y1t. Just like this x2t, that's output is y2t, and that is x3t, its output is y3 of t. So this is a input, it will yield just like of output. Now we can check. How could I check? First, we have to check, select any of the above. Okay, any of the above. Say I am selecting this. Then express any one input in the terms of other input. So the process, what you may apply here, this is the amplitude scaling. It may be inversion, it may be time shifting, or it may be addition subtraction of two or the more signal. Okay, but which things you couldn't perform, which things you don't apply this uh, for this purpose. First one is you have to avoid you have to avoid the time scaling. Second, you can apply mod or modulus. You can you have to avoid the any x square, x cube, this type of terms, because it will leads the non-linearity. Okay, so this is the steps. Now if we go for the example, then you can understand very easily. First, for the linear system, x1 in, this is a discrete system, that is given, that is -1, that is 2, that is 1. It will give you, that is y in, y1 in, that is 1 2 1 0 1. Here it is at the 2, origin is at the 2. x2 in, that is 1 -1, that is also -1, that is also 2. So it will give you, that is y2 equal to n equal to, that is given -1 1 0 2. That is x3n equal to 0 1 1 1, and that will give you y of 3 y3 y of y3n. Okay, so how could I find, that is a LTI system, that is a LTI system. How is that a LTI system? How could I find out? First step was that select any of these above. Yes, I am selecting this one, and then express any of input in the terms of other inputs. So if I express in this input in terms of this, in this input in terms of this, then if I get, yes, the value is exactly coming this value, then this is the LTI. If this exact value is not coming, then it is not a LTI system. This is the maybe linear, because linear is given, but this is not the time invariant system. Okay, this is the, it will not be the time invariant system. So first, this is, I am taking this. So first we select, that is x1 in, x1 in is this, okay, -1 to 1. Okay, so we can just shift this. First we have to shift this, means, okay, I first we have to sum. We are going for the x1 and x2, that is summation. So if we sum this portion, what will you get? Look, -1, this is origin is same. So this is the term. Say if this is your this term, then x1 is, that is -1, and uh, that is 2. That is, here only 2 is there. Here is, it is 1. So if there is a 1, there is a 2, then -1 and is here, and this is also there, and here also there. Okay, this is the 2. Okay, 2 is there. So you can see -1 plus 1. This is -1 and plus 1. Origin, first step. This is the -1. -1 means this is in this direction. This is not in this direction. This is -1 value, means that is in this direction. Okay, this is 2 and this is 1. So this is in this direction. Okay, but this is the x1 in, and if you put x2 in, that is 1, origin is 1, so origin is at the -1. Origin, at origin, this is lies at the -1. Okay, this is 0. This is origin, this is origin, and this is 1. This is +1. This is also -1 in the value of -1 position. This type of signal is there. So if I sum it, then you can be -1. This is -1. This is +1. So this is 0. If 2 plus 2 minus 1, that is 1, and 1 minus 1, 1 is upper, -1 is lower. So that is also 0, and origin is lies here only. Okay, just remember this. Then I will again go for, because we have to express this and this in the term of x1 as the element. So I am just one shift it, n minus 1. If I go for x is there, n minus 1 means this will be shifted over here. It will give you, means minus means it will shift here. So that is 1 minus 1, that is 2, that is 1. Okay, it will shift over here. So it will come here. Here is nothing is there, you may put 0. If nothing is there, you may put 0. So just like this, if I go for x2 n minus 1, which operation is this? This is the time shifting operation. Time shifting. Look, x2. So x2 is here, one shift is there. So it will become just look, 1 minus 1 minus 1. Okay, origin is shifted over here, -1. So this is also 0. You can get by using this. If I add all these things, means that is x1 in plus x2 in plus x1 in minus 1 plus x2 in minus 1. So what happens? what happens? You can do this. Look, you have get, this is the x1 and x2 is given, x1 is x2 is given. So one by one I am writing this. That is for x1, that is x1, that is x1 in, that is x1 in -1 to 1, -1, -1 to, that is 1, that is origin is there, x2 in, x2 in, x2 in, what is x2 in? You can see that is 1 -1 -1, 1 -1 -1. Origin is here. You have to maintain the origin. Okay. So now x1 in -1, x1 in -1 is x1 in -1. What is x1 x -1? That is 0 -1 to 1. Okay, 0 -1 to 1. 0 -1 to 1. Okay, origin is here. Now x2 in -1. Hello, is there any? Hello.
হ্যালো স্যার।
হ্যাঁ স্যার,
আপনার স্টুডেন্টরা কোথায়, বাকি স্টুডেন্টরা কোথায়?
সেটাই তো আমি দেখতে পাচ্ছি না। নেক্সট উইক তো পরীক্ষা আছে, আমি জানি না তার জন্য কিনা আমি আবার কল করছি।
আপনি না কোন সাবজেক্ট পড়াচ্ছেন?
আমি সিগন্যাল এন্ড সিস্টেম
সিগন্যাল
পড়াচ্ছি।
সিস্টেম?
হ্যাঁ হ্যাঁ হ্যাঁ
এটা লিনিয়ারিটি ইকুয়েশন নাকি?
হ্যাঁ স্যার, এটা লিনিয়ার ইকুয়েশনটা, এটা আমরা যে অ্যাকচুয়ালি এলটিআই সিস্টেম কিনা, হোয়ার ইজ ইট ইজ দ্য এলটিআই সিস্টেম, সেটা আমরা চেক করছি। এটা আগের দিনেও
হ্যাঁ, এখানে
একটা,
তো সুপারপজিশন থিওরেমটা অ্যাপ্লাই করতে হতো।
হ্যাঁ এটা তো সুপারপজিশন থিওরেম এখন করছি না, এখন জাস্ট এটা অ্যাড করলেই, আমরা এই দেখুন এটা অ্যাড করলেই জাস্ট এই x3টা চলে আসবে, সেই x3টা চেক করছি। আচ্ছা আমি দেখছি স্যার,
স্টুডেন্টরা কেউ নেই, আমি ওটাই চেক করলাম।
হ্যাঁ 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 নিশ্চয়ই নিশ্চয়ই। Okay guys, and this is x2 n, you can put it the value, you can put it the value what is x2 n, 0 1, that is 1, -1, that is -1. So if you add this, so what happens? Look, -1 minus +1. So it will give you, that is, it will give you, it will give you 0, and this is 2 minus 2. Look, this is sorry, this is -1. 2 minus 1 minus 1 means -2 plus 2. This is 0 and this is 1. So it will give you only 1. Only 1. 1 minus 1, 0. 2 minus 1. So give you the 1. 1 minus 1. So it will give you the 0 also. And origin is, and the origin is there. So you can see ultimately our the output is coming. If I add this, if I add this, ultimately it is coming only 1 1 0. Okay, so 1 1 0 or this type of signals is coming. Sorry, this is a 2 only. Here this is 2, this is -1, this is -1, -1 -2, it is 1. You can see there is something is wrong. 0 1 0, that is 0 -1 2 1, and that is 0 1 -1 -1, and here -1 2 1. So if you add this, you can see this is 1, this is, you have to write this, this is not x1, not x1, you have to write x1 plus x2. So you can add this superposition, or another way, I'm going for here. Look, this is not resemble with any of your input output. Any of your output is not resemble with this. So these things is not required. Okay, so I have to do something so that this may be performed in this y term or y2 term or the y1 term. So again I have to perform, that is, say first x1 in, then plus x2 in, okay, and that is given another, it is added with x1 n minus 1 plus x2 n minus 1. Okay, so just 1 minute. you can write down x1 plus x2 in this term. Is x1 plus x2 you can find that is 0 1 0. Okay, so you can find that is 0 1 0 0 1 0. Okay, and if you add these things, here origin is here, these two terms, if you add this, you can find that is -1 plus 1, that is 0, -1 plus 2, that is 1, and that is only 0. So that is it will become, if you add this thing, that will 0 0 1 0. Okay, 0. So you can also add in this way, you can add also in this way. So all are just like same. So it will coming, actually what will come, it will come anyway, you will perform that, it will coming 0 1 1 0. Okay, but if you perform the input only x1n x2n, don't don't give the output only, don't give the output only, then you can find that is actually x3 is given. Actually this term is, if you add, then only that is coming x3. Actually it is coming x3, x3 of n. How is it coming? You can see that is 0 1 1. Okay, so x3 is, it is coming 0 1 1. Look, that is 0 0 1 and 1. This 0 is not required, this 0 not also required, but we are just resemble with this 0 1 and 1. You can find that is x3 also given 0 1 and 1. Okay, 0 1 and 1. So in this way we can find out that is this summation is x3. Okay, because the value of this is the 0 1 1, and value of x3, this is also 0 1 1. Look, 0 1 1. So we can write this summation is x3, but we have to find out if the value of y3, value of y3 of n is the same, just like this. If I put this, just you do this, x1, its output value is output y of n, x2, that is y2 of n, x1, so it will be shifted x y1 of n minus 1, that is y2 of n minus 1 also. So the value of this is equal to y3 of n, because I got this output, I got this also output. If it is equal, then it is only the LTI system. If it is, if equal, if not equal, then it is not LTI system. This is a time variant system, not time invariant system. Okay, so we have to find out this. We have to find out this. Look, yn and yn minus 1, we are going for the next slide. Look, that is y3 of n, sorry, yn, one, 2, minus 1, 0, 1, it is given, and y1 n minus 1, you can see if we shift this, then it will coming, and here is your 2 at the end of 2. So this is coming 0, 1, 0, 1, 2, minus 1, 0, 1. And if y2 is there, y2 is, that is y2 of n is minus 1, 1, 0, 2. Okay, so then we can apply y2 n minus 1, that is coming, you may shift in this way, that is minus 1 coming over here, 0, 1, 0, 2. So if I add this, if this is resemble of the y3, then only our system is okay, otherwise it is not. Okay, if you add this, now y3 dashed in, it will coming, if I add all of this, that is means, look, this is the 2, this is the origin position, so here is 1, 0, minus 1, 0. So it will gives you only 0, 2, 1, 3, 4, minus 1. So it will give 4 minus 1, that is 3. Okay, that is 1 minus 1 plus 2, that is plus 1, plus 1, 0, only 1, 1. So it will coming 2. Now this is coming 0, minus 1, so minus 1, and this is also second place, this is minus 1 plus 2, minus 1, minus 1 plus 0, that is sorry, this is 2, so plus 1, so this is the 1. And again you can find, here you can see, this is 2, this is y2 is 2, this is 1, sorry, this is 1, this is 1, and this is this place, you can see 1, 2, 3, we have done 1, 2, so 1, 2, this is this place, and this is come 1, 2, 3, so 1 plus 0, that is 1, 1 plus 3, 3 is 0, not required, 1, 1, this is 2, so this is coming also 3, and this is fourth place, so 1, this is 0, 1, 2, 3, 0, 1, 2, 3, 4, only 1 is there, 0, 1, 2, 3, 4, 0, 0, 1, 2, 3, 4, 0. So we only get this one. So this is 1. So this is the value. But this value is not as the y3, which is we have get, that is 1. First time we got, that is y3 value, y2, 1. Where is this? This is not exactly equal of this. So this, it is not time invariant variant system. This is a time variant system. That's why it is not equal. If it will be equal, then we can say that is a time invariant system, and it is linear. First of all, that's why it is called LTI system. Now, next is static LTI system. Next topic is static Now, static LTI system. Why this is called static LTI system? Look, yt is the k of xt. This is a LTI system, but is static because yt is the xt, not any form of yt is the xt. If there is any time shifting property -1 this term, then it will not be the static system. Okay, then y of n is the also k of n, that is not the static system. Yes, this is static system because nothing is there, just k is constant and this is the n only. So this is a static system. If there is a 1, then it will be the not a static system, static LTI system. Okay, so how could I know this? Look, first we have to find out the transfer function, that is y of s is x of s. It will give you this term. This is the constant term. Okay, constant term. So if you go for the inverse Laplace, then we can find that is h of t. H of t equals to k of, and if there is any constant, if we go for the inverse Laplace, then we get a, this is impulse function. This is a impulse function. Impulse function. So impulse function it is given. So this is a static LTI. But any term that is t equal to 0, so it is 1 because it's the impulse. If 0, otherwise t equal to not equal to 0, then it is a static. Okay. So you have to examine so many things so that you can find out this. First A, you have to examine h of t. This is a linear, h of t is linear, u of t. Is that a static LTI? B, that is h of n, that is u of n minus u of n minus 1. Is that a static LTI? Whether it is a static LTI. u of n minus 2, whether this is a static LTI. Or ABCD, another question, h of t equal to delta of delta t. Is that a static LTI? Look, if you go for this statement, then u of t means this is a unit step function. So it has no impulse function. Impulse means there is only exist at t equal to 0 and it will not exist at t equal to not equal to 0. So this is the impulse function, but here this is also exists t equal to 0, t equal to so many things. So this is not a static LTI. Okay. And you can see this function un means this is also there. and one shifted one shifted, this is also the, if you minus this, then only resultant will be coming at the this point. Okay, this point. So this is a static LTI. In this case, un this, and u n minus 2, this is 2, this is 2. So here if you neglect this, if you neglect this 2, then this is a 0 also, 1 also. So your signal is lies at the 0 also. So this so this is not a unit step function. So this is also not static LTI. And this is a delta. Delta means anything multiplication, means it may be multiply over here, may be multiply here, but delta means that is a impulse function, so it is a static. No other functions is there at when t not equal to 0, only t equal to 0, that is the only one pulse is there. So this is also a static impulse function. Okay, now next topic it is coming. Now, next topic is whether this is causal or non-causal. You know what are the definition of the causal? If there is any existence of positive side, then it is causal. If there is anything exist in the negative side, then it is non-causal. And what is anti-causal? Anti-causal means the signal has only the parts in the negative parts, no other parts in the positive. So this is called anti-causal. Okay, so if something is given h of t, I am give you the next slide. Okay, then it is called causal. For this purpose, t less than 0, non-causal. T this time of this t is 0, for t greater than 0, anti-causal. Okay, so if it given to you, that is this is h of t is u of t, whether this is 2, h of t, this is u t minus 1, 3, that is h of t, it is del t plus 2. Okay, then it is coming to the 5, h of t, that is a rectangular t by tau, h of t, that is delta t, h of t, that is delta t plus 1 plus delta t minus 1. So ut only the first part. So this is a causal. This is u t minus 1, means there is some minus 1 portion is there. Okay, then it is, and not causal, not causal. Okay, this is t plus 2. Yes, that is coming 2 minus 2. Okay, and so this signal will be not like this. Your signal will be coming in this way. your signal will be coming in this way. This is anti-causal. This is anti-causal signal. This is anti-causal system. Yes, this is not causal. Only -2 portion is there. H of t, arc t. This is also not, because t of tau, something is divided is there, not linear. So don't go for this. This is only a causal, and this is also, look, here is that -1 and +1. That is -1, that is +1. So then a part is there. So this is not also a causal. This is non-causal. So guys, if you have any question, you may ask me. Otherwise, I'm going to stop here. And thank you for listening.